Okay, so now let's focus on the next module, which is compute and networking. This is a very important module because compute and networking are those very useful services of Azure Cloud, which are extensively used by most of the people who are using cloud. No matter you are a developer or you are an administrator or you are a data engineer, you are surely going to use compute and networking services. Now, when we talk about this module, first we are going to start with a little introduction of this. So let's first focus on benefits and the usage of compute and networking. So we are going to compare what kind of compute types are available in Azure, including these are some of the types, like we have container instances, we have virtual machines, and we have Azure functions. And obviously each type is perfect for a certain scenario. Then we're going to describe virtual machine options. Obviously, you have a choice to create a single independent virtual machine in one of the Azure region, or maybe you can go for a virtual machine scale set, which is a scalable offering where you can create hundreds of virtual machines in one shot. We also going to talk about Azure Virtual Desktop, which is one of the newest service offered by Microsoft only from last few years, which is getting away the pain of configuring virtual machines. You will directly have a virtual desktop, and then your customers, your end users, your remote workers can use that Azure Virtual Desktop with ease. Then we have to describe the resources which are required for virtual machines, and when you create virtual machine, we know a couple of other things are getting created, including virtual network or a disk or drive or a network security group kind of things. So those resources we have to take care and manage. Then we are going to describe application hosting options. Now, when you want to develop and deploy applications on cloud, you maybe have one obvious option, which is Azure Web App, which is a platform as a service. But that's not the only option. We have containers, we have virtual machines. There also we can deploy our applications. Why we are going to use one of the option and what are the pros and cons? We have to discuss about that. Then we need to know virtual networking in depth, including the purpose of virtual network, what kind of things are there inside this, like subnet, virtual network peering, Azure DNS, VPN Gateways, and Express Route. And we have to understand all these concepts in this particular module. And finally, we are going to define the public and private endpoints so that we can understand how publicly or privately we can connect with those network devices and appliances which are configured inside virtual network. So let's get started. First, we have Azure Compute Services. Azure Compute is an on-demand service that provides computing resources such as disk, processor, memory, networking, and even operating system with that. When you're going with the compute services, I think virtual machine is the only service which is infrastructure as a service, which gives you an operating system and all other things which are mentioned. When you go for a compute services which are associated with app service, container instance, or maybe Azure Kubernetes service and Azure Virtual Desktop, these are more or less platform as a services where a platform is going to be pre-configured. A CPU, memory, disk, storage, everything is going to be configured with that based on the SKU, which is known as stock keeping unit associated with that. Now obviously all are coming under the umbrella of compute services, but each one is different from the other one. That's why let's deep dive into this. Let's start with virtual machines. As we have already created one virtual machine in the previous lab, we know that virtual machine is actually a software emulation of a physical computer. So this is going to give you everything what you can do inside a physical computer, but the only difference is this is hosted on the cloud in one of the data center of the cloud. This include a virtual processor, memory, storage, and networking services inside that. It is an infrastructure as a service kind of an offering that provides a total control and customization even at the operating system level. And that's what we already know. Now, this is something which is only one single virtual machine. But in real industry standard wise, when we go for enterprises, we mostly need multiple virtual machines. Sometimes we want scalable virtual machines where if the one instance of the virtual machine is down, we need to make sure the other one is available in no time. When this kind of scenarios are there, we need virtual machine scale set. These are scalable set of virtual machines which are provided with a load balancing opportunity to automatically scale your resources. You can have 1, 2, 3 or maybe 30, 40 or hundreds of virtual machines inside one virtual machine scale set. This scale out feature of virtual machine scale set is going to increase the number of instances of virtual machines whenever the need is going to be there. So whenever you have a heavy load, a number of instances of the virtual machines will increase. And if you do not have a load, then it is going to be reduced also, which you can control manually as well as automatically based on the rule. The scale out and scale in feature of virtual machine scale set is going to be perfect when you are looking for a right amount of resources for the right amount of workload. Same like virtual machines scale set is also infrastructure as a service. When we are dealing with this, we have to focus on virtual machine availability set. To maintain the high availability in virtual machines, we have availability sets and we have availability zones, which simply focus on one particular thing, that you need to have more than one virtual machines available. When you see the diagram right now, this is giving you some words there. Like we have fault domain. Fault domain is mentioned there with the numbers like 0, 1, 2. And then we have something which is update domain also, where we have update domain 1, 2, 3, 4, 5. Understanding these two terms are very important, because based on this you'll be able to understand how high availability is going to be configured with multiple virtual machines. Remember this, guys, fault domain is a configuration of Microsoft Azure Cloud which makes sure that if any fault happens, like power failure, network failure, or maybe some disk failure, when this kind of thing happens, Azure has divided one data center into multiple fault domains, and total number of fault domains are going to be 3 maximum. While configuring our high availability in the virtual machine availability sets, we can choose how many fault domains we want to use in that. If you use 3 fault domains, your virtual machines will be distributed across 3 different fault domains within same data center. And if you choose 2 fault domains, then same way it's going to use only 2. Whenever some fault happens, Microsoft makes sure that one of the fault domain will be impacted, but not all 3. That is something we have created fault domains with the separate power supply, setup, network configuration, and network switches. That's the reason even if the power failure, network failure kind of thing happens, it's not going to impact the whole data center. It's maybe going to impact one of the fault domain. Now, fault domain is something which is helpful in unplanned outage. Now, when power failure happens, we cannot plan it. So that's an unplanned outage. But there are chances that we want to do some planned outage also, like updating the operating system of the virtual machine. When Microsoft plans to update the operating system of the virtual machine, they make sure that they are going to separate the virtual machines into a separate update domains. You can have 20 update domains inside one data center, where they make sure that they are first going to take the virtual machines of one update domain. They are going to update the operating system of that. And if that is updated and running fine, then only they will move to the next update domain. This configuration is going to make sure that not more than one virtual machines of your update domains are going to be affected by this kind of updates. So if you have 2 virtual machines and both in the 2 different update domains, that is perfect, because at one point of time only one virtual machine will be updated and restarted, not all. To understand more about this, you can go through the official learning path link which is available here. This is a learning path link which is taking you to describing Azure Compute and Network Services, where when you focus on this, the virtual machine scale set, and all the services which we are going to talk in this module is available in this one particular page. We also have 2 exercises which will surely important for you if you are planning for AZ-900 certification. Right now, let's move forward to the next topic. Once we understand availability set, this is the exercise which you have to try, which I have already shown you in that particular link, which is creating a virtual machine. This time also you're going to create a virtual machine, but this time we are going to keep in mind that we have to focus on high availability. And that's what which is going to make a difference in certain steps. So please do that. Now, let's focus on next topic, which is Azure Virtual Desktop. Azure Virtual Desktop is a desktop and an app virtualization that runs in the cloud. Now, sometimes I do not want a full virtual machine. I do not want someone to access my operating system level things. I maybe want my employee of my organization, my QA team member, or maybe my HR team member just to use a virtual desktop where they can use certain applications and certain desktop level features. Like maybe they are just an HR who are going to send some email, they are going to configure using Microsoft Office tools like Word, Excel, PowerPoint. Likewise, when this kind of requirement is there, a virtual desktop is a perfect choice for that. This can create a full desktop virtualization environment without having to run an additional gateway or server. Even with one particular server, you can configure multiple Azure virtual desktops. This reduces a risk of resource being left behind, and this is actually going to give you a proper potential of resource utilization. This is a true multi-session deployment, so you are going to have one or two or maybe three servers, but maybe at the same time on those three servers you are going to have multiple virtual desktop configured where maybe 10 or 20 users are going to work. Azure Virtual Desktop is perfect for this kind of scenario. Azure Container Services. Now, I'm sure you heard about the word container if you are familiar with services like Docker and Kubernetes. Now, from the moment we got containerization in the world, it has changed the way we deploy our application. Because containers provide a very lightweight virtualized environment that does not require any operating system management, and it can respond to the changes on demand. Also, when you are deploying containers with Azure, this is one of the fastest way to deploy your applications. Azure Container Services are making sure that your container deployment goes smooth and you always have all the resources available for that. We have three flavors of this container services. First, we have Azure Container Instances, which are a platform as a service kind of offering that runs a container or a pod of a container in Azure. This is, you can count like an independent instance of a container, which is based on a particular image provided into that. Then we have a second option, which is Azure Container Apps, which is also a PaaS kind of an offering like container instance, but this can load balance and scale. So if you have one independent individual container, then I should suggest you to go for Azure Container Instance. But if your client is looking for a load balance scenario where maybe they are going to have multiple instances running and they want to make sure that the load should be distributed across those multiple container instances, then you should go for Azure Container Apps. Even better than container apps, we have something which is Azure Kubernetes Service, which is a Kubernetes service offering available on the Azure cloud, which take care of an Azure orchestration. A container orchestration done by Azure Cloud is something which is available in Azure Kubernetes Service, where you can run large volume of containers and maybe hundreds of containers you can deploy inside something which is known as Azure Kubernetes Cluster, which is also some kind of a global infrastructure kind of thing. It is going to create a virtual machine scale set. So you think like this, that now you're going to have 4, 5, 10 virtual machine kind of environment inside one cluster, and in those cluster environment you are able to deploy hundreds of containers. Obviously, when we have three services in Azure Container Services, for one independent container you go with Azure Container Instance. For scalable containers with multiple instances, you go with Azure Container Apps. And if you really have a microservice kind of application where you need a distributed architecture with orchestration, then you should go for Azure Kubernetes Service. These three services are going to be very important if you are a developer and you want to deploy containerized application on Azure Cloud. After this, there is one more offering which is known as Azure Function. This is also something which can be containerized, but initially it is always used without containerization, Azure Function is a platform as a service offering that supports serverless compute operations also. So this is one of the service which is cost-wise super cheap. I always say this is one of the cheapest way to run your code on the cloud, which is mostly going to be an event-based code, which is going to be running when you call that without requiring a server infrastructure during inactive periods. So this is like you are going to have a piece of code running on the cloud. You trigger that code by firing and triggering some events, and you never need to worry about the underlying platform or operating system or whatever infrastructure which is required to run that code. As long as you trigger that, the event is going to execute the code, is going to give you the response of that thing. And if it is running in the serverless environment, you don't need to worry about the compute operations. Microsoft is going to charge you only for the code execution time. So as long as your code is executing for maybe few seconds to few minutes, you have to pay only for that much time. Now, when we compare Azure compute options, we can clearly see right now that we have three segregations visible in that. We have Azure virtual machines. As we discussed, this is perfect for infrastructure as a service kind of thing. So if you have an existing service on your on-premise, if you have a Windows or Linux-based environment configured and you want to move or migrate them to Azure Cloud with some kind of a lift and shift kind of an environment, virtual machine is a perfect choice for that. If you want to work in the virtual desktop kind of an environment where you have a dedicated applications which you want your users should connect and use, you want to make sure that this should be accessible from any modern browser. You do not want to take a pain of installing those applications in your client machines or servers. And you want a cloud-based personal computer, which is maybe a Windows desktop experience kind of a UIs available in that. With this kind of thing, you can get associated with virtual desktop of Azure. And finally, the third compute option, which is containers, where also we have another nested multiple options, but these are those lightweight miniature environment which are well suited for running microservices kind of applications, which is designed for scalability, resiliency through orchestration. If you are a developer and developing microservice kind of application and services, you are going to convert your application packages into containers, and then these containers are going to be running on the host operating system with maybe multiple containers sitting on that host operating system on the Azure cloud. Okay, next we have Azure App Services. Azure App Services is a fully managed platform to build, deploy, and scale your web apps and your APIs quickly. Now, if you're looking for a platform as a service which is allowing you to deploy your .NET, Java, Node.js, Python, or PHP-based applications on the cloud, this is a perfect service for that. And the good thing is, because it's a platform as a service kind of an offering, it is not asking you to install .NET runtime or Node.js packages, nothing. You just have to create an app service. You choose your preferred operating system, you choose your preferred runtime, and they'll set up the platform ready for you. All you have to do is you have to choose what mode of deployment you want to choose for that. You want to do a code-based deployment or you want to do a containerized deployment, and based on that, your platform will be available to you. Not only that, after creating this kind of an app service, you can scale it. We have services which are helping you in scaling the application horizontally or vertically. So we have a stock keeping unit, we have app service plan, which are scalable associated with that. We also have a separate deployment slots kind of an environment available. If you want to do deployment with the staging slot, if you want to do deployment with the production slot, a separate slot can be configurable inside your app service environment. Now let me give you a sneak peek of this right now. We do not have a separate lab on this in AZ-900, but if I go to my Azure portal, I can click on create resource, and when I click on create resource, this is going to give me an option to create a web app. This is an app service. Remember, web app or app service is the same thing. When I click on create, it's taking me to a page where it is going to ask me what kind of configuration I want to do for that. I can choose my subscription, I can choose my resource group. Let me create a new resource group, which is AZ-900RG. I'm going to choose a web app name. Let's say I'm saying this is Maruti web app with some number at the end of this. I'm going to choose what kind of a publishing mechanism I want to associate with this. Maybe a code-based deployment, maybe a containerized deployment, or I just want to keep it a static web app kind of thing, where maybe an HTML, JavaScript kind of files I want to upload. Now, as of now, let me go with the code configuration first. When I see there's a section like runtime stack, operating system, region, I can choose whichever I want. And when I go to the runtime, I have a different versions of .NET, Java, Node, PHP, and Python available in that. I can choose one of them. Let's say I want to create an application with Python 3.10. When I choose that, they are going to show me that this works only on the Linux-based operating system. So Windows is going to be disabled. Or maybe if I go with the .NET 6, it's going to show me, okay, .NET 6 can be working on Linux and Windows both. Then you can choose which operating system you want from that. The good thing is, whatever choices you're making here, based on that, they are going to create something which is your app service plan. This app service plan, with the choice of your operating system, the choice of your runtime, and whatever publishing mechanism you have selected, is all going to be configured here. You have a plenty of choices available in the app service plan pricing. You can see that we can explore the pricing plans here, and we have feature-wise segregation available in the pricing plans. You can go for some kind of initial plans which are free, or a basic plan for your test kind of an environment, or maybe if you are looking for a real production environment, you can go for a standard and premium plans. According to that, we will be having different kind of CPUs and memory and configurations available for that. This is all about Azure App Services. Let's get back to our discussion now. Now, after App Services, let's talk about Azure Networking Services. Now, we know that we have a virtual network, and a virtual network is enabling you to configure your Azure resources to communicate with each other. Now, when you are dealing with multiple virtual machines, or if you have services like app services are configured, a virtual network can really help you to segregate them in the separate subnet. And then you can configure public and private endpoints so that you can decide that this part or this machine is going to be accessible over the public internet, or you do not want that to accessible over the public internet, and you want to keep it private only within the intranet kind of a network. Now, virtual networking services are allowing you to create a virtual subnet. Each subnet is a fixed range of IP address, and then it is allowing you to configure and apply different kind of security rules on top of the subnets, on top of the virtual network, using something which is known as network security group. Now, once you create one virtual network, you divide that into multiple subnets, and you apply security rules using network security group. There are chances sometimes we want to connect one network with another one. You can create n number of virtual networks in every Azure region with the fixed range of IP addressing, which is a private IP address range with that. If I want to connect one virtual network with the other one, I can use virtual network peering, which can help me to connect my private networks directly. And using this, whatever virtual machines, whatever appliances which are deployed inside those virtual network, I can communicate between them. We have a very good exercise on this on Microsoft Learn website. I strongly recommend you to go through that, where you're going to configure how the open ports are going to be configured to access the devices, how you're going to create a network security group so that you can control the inbound and outbound rules inside that, and then you can configure an HTTP access using the outbound port association with that, with the port number 80, and then you can check the connection whether your virtual machines which are configured on this Azure cloud is accessible through any personal or private laptop or a computer or not. Go through this exercise, and then you can proceed with the next video. Thank you.